I'll just hand it over to you now.
Okay. Thanks, Ron. First of all, I'd like to kind of explain what I thought we'd do for the day. I wanted to sort of talk about the volcano in general here for half an hour or so, and then we'll go over just out here in the parking lot and take a look at it, an exposure of volcanic ash, some of the different beds. It's going to require a lot of off-trail walking, round trip, maybe a couple of miles. It's pretty easy going, but we just don't have a trail to follow. Fundamentally, does that sound okay with everybody? Yeah. Great. I have my dirty clothes on because I'm the one who will be doing the digging. If you have to dig, I'll carry the shovel. So you do get filthy out here. These jeans have gotten, they're beyond repair because when you're working with volcanic ash, you just naturally get there. Okay, well, now we're right here on the Kilauea, and this down-dropped part out here, the forms are called, they're formed about 500 years ago, as best we can tell, and that's based on some recent geological work that I've done and others with me, and then also based on interpretation of Hawaiian oral traditions. And I can get into that at lunch if you're interested. But in any case, the top of the volcano, which was probably another several hundred feet higher than we are here now, collapsed into a void about 500 years ago. And the question is, what was that void? Why was there a cavity there? And we don't know the answer to that. The classical geologic explanation is that there was a big eruption right at the time. The eruption drained the contents of a magma reservoir, emptied. It was no longer strong enough then, but it was just a shell underground to support the overlying summit of the volcano, which then collapses. And the problem is that since we know the age the caldera formed, we know the age to look for a large eruption, and we don't see that large eruption. There was nothing that happened around 1500 or so. About the time that Columbus was making his voyages was about the time that the caldera formed. And so this has led to some speculation as to how the caldera they did form. There was, and among others, there was a very large eruption that lasted for 60 years that immediately preceded the eruption. And the volume of that eruption, the volume of lava erupted in that eruption, just about equals the volume that we think that the caldera had when it first formed. So it's possible that slow eruption lasting 60 years slowly drained the reservoir, which was able to withstand itself until the summit, until there was just couldn't anymore, and then the summit caved in. That's a radical idea. It has some problems with it, but that's one that we're trying to examine now to see if you could have large void spaces empty and getting larger with time, existing for periods of years or decades within the volcano. There are deep mines that are open, of course, to go down more than the depth that would be necessary here. They go down more than 3 kilometers. There are limestone caverns that go down to 2.5 kilometers. So it's not outside the realm of possibility. But anyway, regardless of how the caldera formed, it did form. And since that time, there was a long period of explosive volcanic activity. And we're standing on some of the products of that explosive activity now, probably from 1790. And then beginning right after 1790, which ended this 300-year-long period of explosive activity from 1500 to 1790. Right after 1790, then the caldera began to fill. And it is now filled up to the point where it's about 140 meters, about 400 feet below where we are now, down to the caldera floor. Now, when the first Westerners visited here on August 1st of 1823, the caldera, rather than being 400 feet deep, was more like 1,200 or 1,300 feet deep. And there was a map, a topographic map that was made several years after 1823 that confirms that. And what happened during the 19th century, and what's happening when these people arrived, continued to happen to the end of the 19th century. Then with a brief pause, it resumed until 1924, was that there was eruption after eruption after eruption on the caldera below. The eruptions were coming out of not only Halimau crater down there, but also there was a large elongate gash that extended up toward the north end of the caldera. And there were eruptions that were coming out of that consistently. And that is what erupted all the volcanic ash and the coarser material, such as we have here, some of which we'll be looking at today. That was also a time during the explosions that preceded the caldera starting to fill. That was a time of Hawaiian oral traditions that described some of the explosions too. And you can imagine that how this would go. Pele, the volcano deity, is on the outs with a sometime lover of hers. So one time when they're really on the outs, he tries to kill her, and she throws rocks at him and chases him into the ocean. Throwing the rocks, of course, is one of these explosions. And so you have a lot of stories like that are pretty important in Hawaiian culture. Now, the reason that the caldera is here in the first place is that it is developed over the magma reservoir, which is in turn the cap on a stem of magma coming up from probably 60, 80 miles depth within the earth, within the hot spot. It's you can almost view this as kind of like a champagne glass, or maybe not necessarily a champagne glass, but a glass with a wider bowl to it. You have this narrow stem coming up, then it widens into the magma reservoir. Except the reservoir probably isn't a single balloon like you see shown in diagrams, but instead it's probably more like a sponge. There are a lot of openings and then upright spaces between the openings that keep the openings more or less rigid and open or not, as the case may be. So anyway, the magma rises from through the hot spot up to this level, up to the bowl of the glass, and then it almost reaches the surface. The top of the magma reservoir is within half a mile of the ground surface, about 800 meters or so. And so you kind of wonder why it doesn't just keep on coming up, and why we don't have constant eruption here. And that's a good question. Well, we think the reason is that the magma is just in hydrostatic equilibrium at that depth, and it requires an additional push to get it up to the ground surface. And so, in some respects, it's easier for the magma to go laterally, where it isn't fighting gravity, rather than fighting gravity to rise this extra 800 meters. And so it does that, and that's how the rift zones develop. There are two rift zones, the southwest rift zone, and the biggest one is the east rift zone, which goes off into the distance. That bare small shield on the horizon is on the east rift zone. And Pu'u'o'o, where the eruption is taking place today, is also along the east rift zone. So more magma goes into the rift zones than ever comes out here at the summit.